When working with ontologies or the semantic web in general, one fundamental concept should always be kept in mind. This concept is called linked data. To understand the whole concept of linked data and semantic web a little better, it can't hurt to take a brief excursion into history. The semantic web was proclaimed by none other than Tim Berners-Lee, the inventor of the World Wide Web. He did this in a famous article that was a cover story of Scientific American about how computers can understand information. His vision was that the semantic web as an extension of the World Wide Web would revolutionize the way we interact with computers and the internet. As an extension of the World Wide Web, the semantic web is based on something that is essential for linking data with one another, the Uniform Resource Identifier, also abbreviated to URI. URIs are used to uniquely identify and localize things on the web. URIs can consist of 5 parts. First, the scheme, which is also often referred to as a protocol, defines the type of URI and how the resource should be accessed. Then we have the authority that essentially identifies the entity that has control over the namespace of the URI. The path specifies the specific resource being requested on the server. It's a hierarchical structure that represents a file or directory on the server. In a broader sense, it's not just limited to things in the web, but can refer to any resource identified by the URI. Next is the query. This part is used to provide additional parameters, often for the purpose of retrieving or manipulating data. And finally, we have the fragment. This part of the URI is used to identify a secondary resource, such as a section or a position within the primary resource. It's often seen after a hash. Not all parts of the URI are mandatory. In fact, an URI must only consist of 2 core parts, the scheme and the path. URIs are split into subtypes. Uniform Resource Locators, also known as URLs for short, and Uniform Resource Names, or URNs. As the name tells, URLs are used for unambiguously specifying the location of a thing or resource, for example a website. The URN is used for unambiguously specifying a name for a thing, such as a book through an ISBN. By using URIs, it is possible that one resource can reference another resource without any ambiguities. For example, a resource called pizza can refer to 3 mandatory ingredients called tomato sauce, dough, and cheese. By the way, this example has been taken from the ontology of DBpedia. If you want, you can visit the URI mentioned in this example and see the links for yourself. When linking data, 4 principles were defined by Tim Berners-Lee to classify data as linked data. When working with semantic web technologies, we should try to follow these rules. The first rule is use URIs as names for things. Second, use HTTP URIs so that people can look up those names, for example in the web. The third rule is when someone looks up a URI, provide useful information. Include links to other URIs so that they can discover more things. There's another thing we should learn when we look at linked data, and that is the distinction between linked closed data and linked open data. Linked closed data are usually not available to the public. An example for this could be linked data that are used inside a company or any other type of sensitive data not meant to be publicly available. One of the strengths of linked open data is that it fosters collaboration and innovation by allowing unrestricted access to data. When data is closed, these benefits are significantly reduced. Although it may seem advantageous to keep your data for yourself, This often leads to isolated data, also called data silos, which cannot be easily integrated with other datasets. In conclusion, this is contrary to the principles of linked data, which aims to connect data across different sources. If we make our linked data available to the public, it can be reused by others, and integration of existing data to a huge interconnected graph would be supported. We then speak of linked open data. One of the strengths of linked open data is that it fosters collaboration and innovation by allowing unrestricted access to data. To assess the quality of openness of your linked data, a 5-level concept has been suggested by Tim Berners-Lee, also called the 5 stars for open data. First, data should be available on the web, in whatever format. Second, the data should be available as machine-readable structured data. The third star is the data should be available in a non-proprietary format. You get 4 stars for your open data when these data are published using open standards from the World Wide Web Consortium. And 5 stars are awarded if all of the above is true for your open data and these data are linked to other linked open data. The concept of linked data and open data is a fundamental one when working with semantic web technologies. In most courses, this topic arrives much later after teaching technical aspects first. However, I think when you familiarize yourself with this concept as early as possible, it would have a positive effect on your ontology modeling in the long run. Furthermore, we also got to know the most important component of the semantic web, the Uniform Resource Identifier, in short, URI. If you want to learn more about ontologies, linked data and the semantic web in general, I can highly recommend my Udemy course. There you will not only learn all the basics about RDF, but also about the query language SPARQL, automated inference of new information using reasoning, and developing your own ontology-based apps. You can find the link to the course in the video description.